Hello. Thanks for coming to AWS reInvent. I hope everybody's having a good time. I'm Nathan Thomas. I'm the general manager of Amazon WorkSpaces. Today, we're going to be talking a little bit about Amazon WorkSpaces and AppStream 2.0, and in particular, talking about how those apply to the educational world. So many of you may or may not be aware that AWS provides powerful app and desktop streaming solutions. So the idea here is very simply being able to stream full desktops or individual applications from the cloud. These are provided in a secure fashion, high performance, globally, so you can run those applications and desktops anywhere around the world. You can scale them on demand, so as your business or as your educational needs grow, you've got the opportunity to expand those. And of course, at low cost, paying for only what you need when you need it, and managed in the same way that you manage other AWS services. So how do we apply those concepts to the classroom? So really what we're talking about here is flexible desktops, so that as I can spin up new desktops, streaming them from the cloud for whatever I need for my educational purposes, or I can stand up access to applications from browsers. So that flexible desktop story is kind of Amazon WorkSpaces. The access to applications is kind of AppStream 2.0. So how do we integrate that into the educational process? Well, we think about this in terms of the three kind of users that we serve as a product set in the educational world. That's the educator, the end user, the student, and then the administrator. So let's talk about the educator experience. As an educator, why do I care about this? What am I going to do with it? So the goal is that you can integrate WorkSpaces and AppStream 2.0 into the content that you're creating. So it's not just that this is a simple tool that you're going to use, but it's part of the process of developing what you're going to develop. So how do you build content around the applications that you need? So are you going to stand up labs? Are you going to stand up environments for students to have access to those applications and then integrate that into your content development and your classroom experience? This is really powerful when you realize that those applications can be Windows native, so they can run standard Windows applications, whether that's, again, streamed in the full desktop context or the application context of AppStream, and they're the real-world apps. So the same thing these students are going to see out in the field. So it's very helpful for certain types of technical education in particular. It allows educators to experiment with less financial impact. So you don't have to go get capital expenditure budgets and build out labs and buy hardware and all kinds of things to go test, say, a VDI solution or even a physical hardware solution. You can stand up a workspace or an AppStream environment in minutes, just pay a few dollars to get going. You don't have to waste time worrying about infrastructure and user environments. So ideally, if you're an educator, you're thinking about educating and how you're going to go impart the ideas you want to convey to your students. You don't want to have a bunch of technology issues get in the way of that, so making sure that your environment is up and running and available and scalable. And of course, it gives you the opportunity to expand your educational focus and target to a global reach. So you've got a wide range of AWS data centers across the globe. You've got this environment available in those ranges so that you can go out and have a much broader global impact. So it's pretty powerful. Now, if you're a student, what are you going to get? What are you going to see? So first off, you're going to use real-world applications. You know, if the application that you need is something that you're going to see in the job market, you're getting it right there, it's available to you, and it's scaling. You're going to connect from any device. So if your teacher is built for you or your professor is built for you a virtual lab environment where your applications are, you can have a Chromebook, you can have a Windows laptop, you can have a Mac, you can have an iPad or an Android device or even a Chrome browser or Firefox browser. Just connect from whatever it is you have. That's pretty powerful because it means it really levels the playing field for students. So you've got any device regardless of what is available to the student, and then they're getting to the same environment in terms of the power of the applications that they're able to communicate with. It lets the student persist apps and data over years. So in the traditional world of I'm going to go build a hardware lab in a building, and that's the way that I'm going to give my apps to my students, that tends to go away over time. So they interact with it, and then it's no longer there. With these environments, WorkSpaces and AppStream, you have the opportunity to persist that data or even persist the whole environment. You can leave a workspace in a shutdown state ready to go. It lets the end users separate their personal and academic worlds. So today, a lot of times students are doing things for their coursework and their personal lives on the same laptops, a lot of times issued by universities. And so that can lead to some unfortunate situations, particularly around security, but also around intellectual property and other conditions. In these worlds, you're keeping your intellectual property, you're keeping the security environment in the cloud with AppStream or with WorkSpaces, so it means you can really lock that down and control it a lot better. None of that data lives down in those environments that students are using. And last, the administrator experience. So for an administrator, the goal here is to empower the educators. I think everybody who is in that side of an educational environment really sees that as the goal, to have happy, satisfied, empowered users and educators, but do that in a way that's still manageable and lets you go home at night. And so these really have that goal in mind. So scaling up and down with the academic calendar. So that is spin up more workspaces, spin up more AppStream environments, and then when you're done with them, you can turn them off. So that means your financials change dramatically, and they really match to the actual need of what you have. Automate the environment creation. So use the APIs to just spin up new workspaces or spin up new AppStream environments as needed when you see the need. So you can take out the need for a lot of manual setup of whether it's physical labs or even virtual environments. And then, of course, managing fleet and costs through the AWS console. So we have a whole bunch of tools on this front, but at the very least, I'll say for workspaces, there are automated tools which will let you identify when a workspace is being underutilized, when it would be cheaper to run it in an always-on or versus auto stop or vice versa, and make those changes dynamically. So you can do a lot of things to optimize cost through the tools that are available. Monitor and alarm on fleet health with CloudWatch. So you can treat this a lot like you do any other AWS asset, any EC2 instance or other places where you want to have alarming that tells you, hey, your instances are unhealthy or there's some kind of problem. You can be aware before students and educators come to you to complain about the issue. And then really powerfully, you can build self-service user portals. So we have a lot of customers who do this. I know Greg's going to talk a little bit about some of these ideas from his side as well. That let the end users or the students come and self-remediate issues. So rebuild workspaces, reboot workspaces, make changes to those environments so that they don't have to come and be a burden on help desks in a physical world the way that they would in the past. So I was talking a little bit about AppStream 2.0 and workspaces. We're going to pivot a little bit here and talk just about workspaces, and then I'm going to hand it over to Greg, who's going to take over and tell you a little bit about his environment, what they built. But workspaces are very simply fully managed cloud desktops that are really going to try and provide a full native Windows-style experience for streamed desktops in the cloud. So a lot of the value propositions here are exactly the same as you see for the rest of the AWS services. So first off, pay as you go. So when you start up a workspace, you can pay as little as about $7 a month total for an auto-up workspace. And then there are always on workspaces. So you really only pay for what you use when you use it. This is actually getting more powerful in December. We were just pre-announcing the availability of customers being able to move between bundle types. So you can increase from standard workspaces to power workspaces or performance to value, shift those around with a simple reboot. So you can kind of have close your laptop, open your laptop, and it's a totally different machine. So a lot of opportunity to save costs there. It's simple to deploy and manage. So you go to the console, launch a workspace. It can be as easy as 15 minutes of getting everything set up and you're ready to go. Your workspace spins up and then you're connected to it from the client. So pretty straightforward. Of course, security is a core goal, and one of the main reasons that Workspaces is secure is that the data never lives on these physical devices, these laptops that leave the building and are exposed to all kinds of unique threats. All of the pieces for Workspaces live in the cloud. You're running a desktop in the cloud, you're connecting to it. All that's streamed are the pixels, it's the video output, right? So you're never having that data live locally. It also means because you've segmented that user environment for the students from that environment where they're running their educational environment, you can make it a lot tighter. You can have tougher security on that. They have their own ways to get to the internet and do things on their own devices. And then finally, it's really designed for scale and consistent performance. So I get a lot of questions. People wonder, how we can set the pricing that we do without doing some sort of shared session or oversubscription. We're really running full virtual machines for every workspace, so it gets its own dedicated pool of RAM and CPU and disk and network. And so our goal is to solve some of what is a perception of a negative legacy of virtual desktops by saying, look, everybody's going to have phenomenal experiences at all times, so the interaction is going to be very high quality. So with that, I want to transition and introduce Greg Smith, Vice President from AcceleRed. Greg has done some incredible stuff with WorkSpaces, and we really wanted to have a chance to dive into some of what he's built and talk about that a little bit more.
Thank you very much. So as Nathan mentioned, I am from AcceleRed, but we just recently transitioned out of UMUC. AcceleRed is the University of Maryland University's college IT organization. So we took what we had done at UMUC, so I'll probably bounce back and forth between UMUC and AcceleRed during this, so that's the background on this. About a year and a half ago, the academic team at the University of Maryland University College approached technology and said, we have a problem. We have this issue where our students can't connect to these virtual resources. They can't get access to applications that they would need in the real world, and we need some help. And so University of Maryland University College, being an open university, the largest online public university in the US, we deal with students who are very basic technology users all the way through the more in-depth technology users. So we needed to provide a solution that was very simple, easy to use, and that was not support intensive. We see technology challenges are the major barriers to student retention, which is important, but more important is the student success and the student's ability to learn the material in the classroom and be able to take that and apply that to the real world. So we created a student-first or student-centric technology based around the AWS stack of services. So it's not only just WorkSpaces, which is key and core to this, but we extend to Lambda and DynamoDB and EC2, Autoscale. We basically name it, we use it in the platform that we've wound up delivering to our students. The piece about persistence that Nathan spoke about just a few minutes ago is really important for our program, because what we want to do is, as a student progresses from MBA 1 class to 2, 3, 4, and 5, give them the ability to have the same set of tools and build on their learning experience. So competency-based education and being able to take lessons learned in 1 class and apply them in the 2nd class, or 3rd class, or 5th class. It needs to be available wherever, and our students are at the Starbucks around the corner here in the Venetian, or in a tent in Afghanistan taking classes. And so we needed a platform that could be available, reliable, anywhere. We talked a little bit, Nathan talked a little bit about integrating into a classroom. And this was an important piece about what we were doing, right? We couldn't have just another tool, right? Where you have a disparate user experience. A student approaches this as yet another thing they have to log into. The legacy platform that we were using for 1 course actually required them to VPN in and required them to use up to 7 different passwords to access and complete their homework assignments. So that was obviously not a pleasant user experience, and because of that, obviously lost students in that process. So what we did, working with the WorkSpaces team, is that we created and launched, the WorkSpaces team created the web client, and we created an SSO integration into that client to launch from our classroom. So it seems like it's integrated into that classroom experience. So there's no additional username, no additional password. You click the link and you're into the experience, whether you need to use Crystal Ball or any other specialized application in your Windows 7 environment. So WorkSpaces is really the backbone to all of this, but as I said, we're using virtually all of the stack. So Aloft by AcceleRed is our marketing name for the products that we're taking to market, and we can talk about that some other time. But what's really important is the technology that was built that feeds Aloft by Everywhere. This is a fully automated provisioning system. So a student who enrolls in one of our classes, whether it's MBA 610, Cyber 650, Environmental Management 451, winds up in our Desire to Learn platform. 4 hours from the time in which they are provisioned into our LMS, or Learning Management System, we gather that information using Lambda scripts and provision out their workspace using the APIs that Nathan referenced. And that when the student gets access to that classroom, which is by our business rules 7 days ahead of the class start date, all of their tools are ready there and waiting for them. So there's no going to a website, downloading a virtual machine player, installing it on your local laptop, making sure you have the specific requirements. You need a Windows laptop, a Mac laptop, this amount of RAM. All you do is click a button and you open up a web browser, Chrome, Firefox, and you're able to access the resources that you need. We deliver the software using Web Application Manager, Workspace Application Manager, to each individual workspace based on their enrollment in their course. So MBA 610 might require Project in Visio, whereas a cybersecurity class might require FTK, access data, those kinds of applications. And all of that is done based on their enrollment information. It also allows us to manage the licensing that goes on in the background. And then we're able to connect via one click in the workspace a student to a lab assistant or a teaching assistant for technical support should they need it. One of the interesting platforms that we built as we were rolling this out, because WorkSpaces is absolutely fantastic, and there are classes in which we needed to expand that platform. We needed to create a way for a student to get a experiential learning, hands-on to applications and tools that they might not have access to in their day-to-day work before they get their degree, but stuff that they would have access to in their normal jobs once they graduate. So if you envision a cybersecurity team, a red team, blue team exercise, or an ethical hacking exercise where a student needs to have a copy of Kali Linux, a unsecure version of Windows, I could probably just say a copy of Windows, and a Linux environment in which they can interact, hack, break passwords, break the systems, make them unstable, but in a secure, contained environment. So in our world, that starts with WorkSpaces as the entry point to that. And we layered on a tool in which a tool that we built, in which a student can provision those resources based on the lab assignments that they're doing at the time. So as a cybersecurity student, I log in. I need to do an ethical hacking exercise against a Windows machine. I need to break some passwords. I go into my lab assignments. I click provision. I'm leveraging auto-scaling groups. I'm leveraging EC2 instances, security groups to make it all nice and secure so you don't have access to the outside world. Other students don't have access to your instances. And I'm able to perform that. And then I'm also able to show my instructor what I've done. So it gives a student hands-on experience that they wouldn't have access to unless they were working really hard on the technology for themselves, which is not what we're in the business of. We're in the business of delivering a learning experience, not letting technology get in the way of that learning. So as a part of that, we also use the S3 platform for data storage. We're able to, I think I mentioned, use security groups to restrict web access and restrict access across the environment. But in addition to cybersecurity, this plays a role in database design and development, database administration, simulations, an application that we can, and that we're working with in art school that struggles, and let me know if this resonates with you, but having the resources available for finals time or exam periods in which you don't have enough resources on campus to provide rendering farms for students who need to submit assignments, and that, for example, Maya needs a bunch of resources and you're spending millions of dollars to put that in your data center and your basement and support it and manage it, and you still get a lot of heck from it from your students because it's not available and not fast enough. So we're working with them with this tool and with WorkSpaces to make that available to their students to do on-demand rendering farms. So there are a lot of applications that you can think of beyond just the ones that we've talked about here. The reason why we did this in Amazon was because we had the flexibility of a true cloud environment, right? We didn't have equipment in the basement. University of Maryland, University College went all into the cloud in 2014. So we got rid of 5 data centers, and we weren't about to start introducing them with this. Excuse me. The system specs barrier that you're used to dealing with, what does my student need? Do I need a Macintosh or Windows machine? How much RAM? How much processor? Those things that you send out to your freshmen that they get inundated with material. We don't have to worry about that, because whether you're using a Chromebook, whether you're using a Samsung S8 with a DeX, it all works because you're leveraging the WorkSpaces platform as your gateway to your learning environment that sticks with you as you go through your program. We're able to deliver powerful applications that wouldn't necessarily run on lower-end devices or the specials that students get for graduation. We're able to scale up and down the resources across campus. So we're up a little over, actually it's just under 11,000 students who are using the platform today. And we've been able to do that over the course of a year. We launched with 400 students the last day in August of 2016. By the first day in October, we were already up to 3,200 students using the platform. And from October 2016 to today, we're now up to about just under 11,000 students who are using this platform. Because it's all automated, all integrated into the API environment, we're able to integrate into the learning management system. We're able to integrate into the log flows and alerting and management. We're able to automate all of that and not have a heavy-duty staff to maintain and manage that. And we don't have to maintain that basement full of hardware. So the final piece is the rigor of academics should be in the classroom, the learning and the teasing of the brain, not in the process of getting there. And that's what we've done with this platform for UMUC. So with that, Supreet.
Thanks, Greg. I think it was a great case study to see how universities are using higher virtual desktops. In the next half of this presentation, we're going to look at how some of the higher education and K through 12 are using Amazon AppStream to deliver applications only. Like we talked about how universities are using full desktop, but if your use case is around, I just want to deliver applications and not want to manage the desktop. So we'll talk a little bit more about that in the rest of presentation. So Amazon AppStream is a fully managed application streaming service that allows you to deliver only applications to your end users. We deliver to HTML5 browsers on any device, anywhere. So this basically allows your end users to take an application-centric view. We achieve this by running your applications next to the data, and then we try to match the right compute profile that's suited for your application. If it's an analytical application and requires a lot of memory-based applications, then we use memory-based instances. Let's say you're running a CAD/CAM application and you want GPU-based instances as a prerequisite, then we match that with the right application profile. And just like WorkSpaces, we also send an encrypted pixel stream to the browser, so the data and your applications are always secure in Amazon AppStream, and we deliver app-only experience. So some of the benefits I want to kind of quickly go over are, first is we allow you to run your Windows applications unmodified in Amazon AppStream. So this allows you to take your applications that you have written and to deliver to any device. A very common use case that we see in K through 12 is teachers want to deliver the Windows applications that they are predominantly using, but deliver it to Chromebook. So a student opens up a Chrome browser, accesses the Windows applications like they are doing. Another use case that we commonly see in higher education is a lot of CAD/CAM applications are written for Windows operating system. So, but we do see in higher ed, a lot of students end up using non-Windows devices, so such as MacBook. So you open up a browser, bring up your applications, and start interacting with them. The second benefit of Amazon AppStream is we try to give you the web app experience. So we want, just like when you open up a browser and you go to any of your favorite portal, you see those applications or the web portal loading up instantly. We try to optimize your application such that you can get the same instant-on experience. The third one is your applications are secure and along with your data in Amazon AppStream, because these instances that are running your applications are never exposed to the internet. And two, these instances are actually provisioned in your Amazon VPC. So you can set up your custom security groups, you can set up your policies and controls, access controls to kind of make sure your instances are secure. Second, the data is also sitting in your Amazon VPC, so you can access this data also through these instances in a very secure way. The other tenet that we took when we built Amazon AppStream is we wanted to make sure your Amazon AppStream works with your IT. So what I mean by that is we want to make sure your AppStream instances work in your VPC where you don't need to open any new ports or firewalls. So we stream over HTTPS, so you can just like how you access a web page. We work with your identity, so if we support Active Directory, we support domain join instances, so we gives you the single sign-on capabilities. We support SAML 2.0, so if you are using Ping, Okta, or Shibboleth, you can just do a single sign-on access. Similarly, since the instances are domain joined, if you are using network file shares for providing data access, so you can continue to use them. Or if you're using SCCM, for example, to deploy applications, you can continue to use them. So we kind of work with your IT. So our goal is always to make sure these instances are in your VPC so it continues to work as if they were in your corporate resource. In addition to that, we always give you a built-in identity, a built-in storage backed by S3 in case you don't actually have an existing infrastructure. So this is a way for you to kind of get started quickly. The other big benefit of Amazon AppStream is you don't have to manage anything. This is for our customers who really want to take an application-centric view where I don't want to manage the desktop. The instances are non-persistent. We believe in bringing your applications, data, and the right instance profile at runtime for your users and give them the right best experience. So we store the data in home folders that are backed by S3. So when we bring the data back, we provision the applications at runtime, and then we kind of give you a runtime environment on the fly. At the end of the session, we terminate the instance, so there's nothing to manage. We always bring up the latest and the greatest version of the software, as well as the operating system there. And then the last benefit is, just like any other AWS service, we are available in multiple regions, so you can pick the closest region that's available to your workload, and so that you can actually provide a consistent performance. We don't do any time slicing of CPUs, so each user gets a fully dedicated VM for the duration of their application that they're using, and they can choose the right type of instance as well. So you can start with, for example, a really small, for a knowledge worker workload where you're starting with, let's say, a standard instance type, and then later that user happens to end up using an analytical application. You can stop your instance, immediately switch to a higher profile instance to kind of get a better performance on the fly. So we kind of give you the consistent performance experience. So those are kind of some of the key benefits of Amazon AppStream. With that, what I wanted to do is introduce Marty Sullivan from Cornell. They are going to talk about how they're actually using Amazon AppStream to deliver applications in their virtual classrooms as well as in their labs. Marty?
Thanks, Preet. Hi, everybody. I'm Marty Sullivan from Cornell University. I think I have a unique perspective when it comes to delivering IT to students and also being a student myself. So I'm a master's student in information science at Cornell. I do take a lot of senior level undergrad courses as part of that master's degree. And I also work for the cloud team at Cornell. So we do a lot of things DevOps and IT based. And I was really interested to take a look at delivering software to students, because before this position, I worked for atmospheric science at Cornell. And I managed a computer lab for them, and I also managed several systems and did some software development, really a wide range of things. So I always wanted a way to simplify the management of those systems that students use. So how about a little bit about Cornell? We are an Ivy League institution. We have a lot of students, as you can see, both undergrad and grad students. We also have a lot of faculty members. We're located in beautiful Ithaca, New York. I actually grew up in Ithaca, class of 2007 at Ithaca High School. So the place is very close to me. So at Cornell, our delivery is always about security, security first. So we offer many different pieces to students so that they can have a secure experience while they're accessing their software. So we offer LastPass, we offer Blackboard, and all things that are integrated into our single sign-on system in order for them to access those things. And we also offer two-step login for all of these services through Duo. Now, we have a lot of computer labs on campus. I didn't count how many there are, but you can see on this map there are quite a few that are managed by several different groups on campus. Some are managed by the central IT service. Others are managed by different colleges, or some, like in the one that I managed in the past, was just managed by me, a single IT person in a single department that was just for one science curriculum. So with a lot of these labs, there are a lot of challenges for the students, especially around things like, being a student myself, I always want to use my own computer, but that's not always possible with a lot of the software. For example, because I use a Mac. I took a course in rapid prototyping last year, and we needed to use several Autodesk products. The only way I was able to do that was to put a virtual machine on my computer, which was fine for me, but I think the experience most students had doing that was not so great. And I was really limited by my machine itself too. I mean, I couldn't, you can't get performance out of this laptop that you would expect from a traditional lab machine that was set up to run that software. And also there's things like access restrictions, a lot of the course software is delivered on a lab machine that has access to particular file share where all of the course documents and files for that application are stored, and you can't access those if you're not in the computer lab. There are also a lot of faculty challenges. In particular, the thing that I always ran into with the lab that I supported was faculty have to fight over scheduling their courses, which is very frustrating for most of them because they have to schedule their teaching schedule around the availability of a computer lab. And the students can't use the computer lab while they're teaching in there. So if this lab is the only place on campus that you can access a particular piece of software, you have to go there during, perhaps late at night. During the winter, you have to walk across campus. In Ithaca, it's very, unpredictable weather throughout the year. We're also dealing with fixed classroom sizes. You can't offer a course with more students than there are computers. So that's a huge limitation, and because really many professors would like to deliver as many, they would like as many students to come into the course as they can. And also from the IT perspective, there's just so much to maintain, and there's so much to worry about in security and compliance. And anytime a professor has a change that needs to be put into the software, it usually requires a complete reimage of a machine or some similar lengthy process. So why did we choose to use AppStream? Well, we really were looking for something that, like I said, was easy for people to use. But I think a lot of the faculty had envisioned a service like this before. In fact, many of our units on campus had attempted to deliver VMs, either using on-premise hardware or cloud virtual machines. So this concept has existed for a long time, but I think with AppStream 2, we've reached the point where it's both affordable and offers the performance that people would expect from a service that can deliver applications. There's the flexible pricing. It's great that we can deliver a very complex piece of software to engineering students, while other students who might just need access to the Microsoft Office suite can use a smaller instance size. And the security benefits are great because they're all in a secure VPC. All of the systems that are running in the cloud are in a secure network. We can put resources within that same network that those applications can connect to. And I'll talk a bit about that with the course pilots that we've done over the past year. And we can, control who can access this. And everything is through our, existing single sign-on system. And we use Shibboleth at Cornell, and we've integrated the SAML authentication that AppStream offers, and that gives the students a great experience for accessing this. So what are the benefits? A student can use any device that they want now. I can use my MacBook. A student can use their tablet, whether it be an iPad or an Android device. So they can bring that item to a class and use it to access this powerful software. It enables online and distance learning that wasn't possible before. We have one professor who's considering the idea of delivering, he does a massive online open course, or a MOOC, and he teaches to upwards of 20 to 30,000 students from international areas and the US, and he's seriously considering using this to deliver software to those students. And really, it's just the basic things. The students can access their software from anywhere. They can be at home, they can be across the country, they can be, at the cafe. For the IT people at Cornell, really what we're trying to solve is making application deployment straightforward and not tedious. Because I think that a lot of the time that people spend setting up computer labs and different machines to run different types of software is really spent doing things that are very repetitive. And those things we, in the DevOps side of the world, like to automate as much as we can. So the tools that AppStream offers, which is usually what all the Amazon services offer, is a lot of automation and API access to do all of these things automatically. So I'll talk a little bit about the two pilots that we have done at Cornell. We have delivered to about a total of 200 students so far. We're planning on ramping up in the next semester and actually delivering to a lot more now that we've sort of proven the technology on campus. The faculty are really excited about it. The ones who have tested it really want it again next semester, and we've been advertising it around to faculty who hadn't seen it before, and they're asking, how do I use this? So the first pilot that we did was for some more complex software. The applications we're delivering are ANSYS Fluent. We have MATLAB in there and a few other pieces of software that require a decent amount of system resources. So in these courses, the students are designing items in the world. So say like a windmill turbine. And then they use programs like ANSYS and MATLAB to actually simulate how that windmill turbine would work in the real world. And it allows the professor to give them feedback and how they've designed their part. And by the end of the courses, they're able to then have designed a useful part. And the second course is quite different because rather than delivering complex software, we're delivering more client-based applications. So this course is a business intelligence systems. It's actually a newer course in information science at Cornell. Most of the work for these applications happens in an Oracle database running in Amazon RDS. So that database is running in the same VPC as the AppStream instances. And they use applications like Oracle SQL Developer and Tableau and WorkSpaces Red to actually connect to and run queries on that database and do other business intelligence analysis. So the interesting thing about this course was that the instructor came to me and said, it's a brand new course. We don't have a computer lab to put it in, and they're telling me to go to the central IT, the lab service to help deliver this software. It was like a month before the course started, and they just didn't have time to work this in. So he was looking at having to have the students run these pieces of software on their own computer, which really would have been a support nightmare. So we, got creative and said, Amazon's got this new service that we can use, and we tested it out here, and it worked, great. So we were able to put this together in less than a month and deliver to over 50 students in this course. So I'd like to sort of go into a little demo of things that I'm putting together on both the student side of things and the IT side of things. So I'm going to switch over to my machine here. So I've told them, we need to hire a web developer to help me because I'm not, that great at designing websites. But I'm a functional person, so I like to make things that work. And somebody else can come in afterward and fix things up. So I threw together this web interface for students in the spring semester. We're gonna start delivering this at a larger scale so they'll come to this portal and be able to do things. And also there's some tools for tech support providers to do things. So first let's take a look at what the faculty and students will see. So you can see that we've built in our single sign-on to this interface. And I'm doing my two-step. At this point, these are the two courses that we're delivering to for the pilot. We'd like to put some more access controls onto a page like this, so students only see the courses that they're enrolled in and similar things like that. So at this point, we've reached the Amazon single sign-on page. The students won't actually see this page because they will just be enrolled into a single account. Since I'm on the cloud team, they throw me in so many accounts I can't even count them anymore. This is what the student will see when they log in. And this is for that mechanical and aerospace engineering course. So they'll see this catalog of applications that we've set up for them. So just as an example, I'll open up MATLAB here. I think I already have Inventor open, so you can just go here. And you can see that, I just wanted to show you that, these applications are running as if they're on my desktop. We can move files back and forth to here, and they have a persistent storage area, which is also offered through this service. It's built in. And all of that was pretty simple to set up. So that's what the student experience is, and the faculty experience. I think it's great that the faculty and students can have the same environment to work in, because oftentimes you'll find that a faculty member has things set up a certain way on their machine, and it's hard to reproduce that for the students. And this way we can tweak things to be set up the way that everyone expects it to be set up. So some other interesting things that I have been working on the tech support side of things is to automate a lot of the deployment of these applications to AppStream. So I just put together this quick interface. AppStream has the concept of an image builder. Essentially, the image builder is just a Windows machine that you go into and you set up your software on, the same way you would on any other Windows machine. And then it has a way to then catalog some applications that you want the students to be able to use. So in this case, we have set up these packages. We're using a well-known Windows tool, Choco or Chocolatey, to put together packaging for these applications. There's no reason you couldn't use Microsoft's config manager or any other deployment method for these pieces of software. So the idea is we'd like to be able to have somebody go in and set up their image the way that they want. And then click a button and then everything is going to be set up. So we're using Amazon's step functions. So we have a state machine set up that goes through and will create a session with credentials for the image builder, and then it goes through a bootstrap process and installs those packages automatically. Completes the imaging process, and then allows the technical person to actually go through and test the applications. I think that this is really awesome, and I'm planning on making this work open source and sharing it with other universities. So I would keep an eye out if you're interested in using AppStream. The beauty of this is it satisfies all of my DevOps, check boxes. We're using infrastructure as code for everything here, so we've got everything deployed with CloudFormation. Everything's serverless, from the web interface to everything. I mean, I would even consider AppStream to be serverless because you aren't managing any actual systems. Any systems that get spun up are temporary and are replaced every time a new person comes in to use it. And I love the state machine concept. It allows you to keep track of, the time everything takes. This is a image that I completed earlier today, and so you can go through and see sort of like how long each step is taking and how you can improve your imaging process. But most importantly, it gets rid of the tedium that the IT people setting up these pieces of software have to deal with every day. It reduces all of the point and click things that they have to do and allows them to completely concentrate on packaging the applications, because that is what they're skilled at, and what they should be doing is spending their time configuring the applications the way that the faculty needs them to be configured, and to be able to change those things quickly, keep their scripts and source control, and be able to collaborate with all of the other units on campus that are managing their own software. This allows us to work towards centralizing application packaging on our campus, which is a huge goal of mine. And this that pretty much covers everything. So.
All right, thanks a lot. Really appreciate you guys coming up. I think these stories and talking about, how do I switch this back? This guy. Stories and hearing a little bit about how this is getting used in the real world, I think is pretty powerful. To me, it's just incredible to hear how the application of these cloud concepts, APIs, and automation really transforms what was kind of a core help desk style function in a lot of ways, desktop provision, into a true DevOps approach, and you're doing development work around innovation on the desktop and the provision of applications. So it's just hugely powerful. We've got time for some questions. I did want to have a couple of call-outs before we get in. First off, I want to say thanks to our presenters. Thanks, guys. Really appreciate having you guys up here.